period of oscillations of this block. So what is the method? This is at mean position. You have to recollect ideas of the vertical spring block system. So this will be the spring. I'll pull the block by a certain distance, say like a amplitude, I'll give A. Release from rest. So this is at equilibrium. So initially how much? Kx naught, this is mg. This is at rest, no? Release from rest. And by the time it comes here, it will be having certain velocity v. Let it be elongation x. So how much of this will be the mean position. This will be mean position, and this is a natural length of the spring. This is the elongation initially x naught. So how much of spring force will act now? K x naught plus x. And it will come back to one oscillation. I'll show it so that will be easy for you. So then it will come back to mean position. Here it will have maximum velocity. Let me take it somewhere here. This is a natural length of the spring. L naught, I'll write it. Keep this in mind. It's going to help us a lot. Okay, now the block will be somewhere here. The spring, what happened now? Still it be elongation only. Say some kx dash. Okay, this is the elongation. Still it is elongation only, and it will have say some velocity. And finally, what happened? It will come to instantaneous rest, and this will be the amplitude E. So again, after this position, the block what happened will come back to again mean position. It will have maximum velocity. So I agree this. So then this is what one sequence that will happen. K x naught plus x here mg, it will undergo retardation. So this will be one oscillation. So what did they say? I am going to pull it down. I'm going to pull it down and release it. Then a spring force of K will act. That K will be greater than mg because earlier Kx naught was mg. So how much of spring force will act? K x naught plus A will act here mg. So the block will accelerate. Then as it accelerates, speed will increase. Okay, I agree this one. Then the elastic potential J decreases, gravitational potential J decreases, kinetic energy will increases. Then come to mean position. So this is the mean, you can call it. This is the upper extreme. This is the lower extreme. So in every problem, what happens? You must notice this vertical spring block, upper extreme, lower extreme. What is my question? I want the time period of oscillation. This time period of oscillation depends on what all. So I'll look at this particular position. What is the restoring force? Earlier Kx not equal to mg. Now what is the restoring force? Kx naught plus x minus mg equal to me. And how do this force will act? Opposite to displacement, no? Because the displacement was given like this, the force is acting in this direction. Okay, this so you put it negative sign here. So Kx not equal to mg will get cancelled out. So therefore Kx equal to minus ma, or A equal to minus Kx by m. Compare this with standard equation of SHM. What is omega? Omega square is K by m, or omega equal to root of Km. So T equal to 2 pi by omega. Okay, this time period depends on what? Depends only on the mass and the spring constant. It is independent of what, like the gravity or any other thing, or independent of amplitude of oscillation. How much you give amplitude, that will not determine time period. So what is this T? T independent of x naught and A. What is the amplitude given? how much you pull down the block and release, that will not determine the time period. The time period depends on mass and spring constant. That's what he's saying. Okay, this is about the force method. So always what happens, you should end up with this equation, acceleration proportional to negative of displacement. This is a standard equation. Compare these two, then in place of omega square, you have Kn, then T equal to 2 pi by omega, then you'll get the time period. This is about the force method. What you studied is force method. So what is the methodology you have to develop? The system given will be at equilibrium position. You should disturb the system. From mean position, either you move the block up and release, or pull down the block, release. Then what are the restoring forces that are acting? Then write this equation. Why negative sign? Because the displacement was given downward and the acceleration is acting upward. That's why this negative sign we have brought it. Okay, this is about the force method. Let's go for energy method. The same analysis.